Well, welcome back to the shack. Today I want to talk about the way that a technician determines the success, the measure of success of a repair on a vintage tape recorder or turntable. There is a measurement called wow and flutter. You probably have heard of it. And in basic terms, wow and flutter is the distortion that is heard on the tape or on a turntable. So in the reproduction of sound on a turntable or a tape recorder, there are irregularities caused by drive speed. So it could be the tape drive speed or it could be the turntable speed. And the irregularities create a waver in the sound that is discernible by the human ear. And depending on how much wow and flutter, which is the measurement standard is percentage of wow and flutter, will determine the quality of the sound that is reproduced by the device, the tape recorder in this case. In this video, I'm going to test, during the period of this video recording, I'm going to test 12 different tape recorders, 11 or 12. And we're going to use a free piece of software that I found on the internet. It's a little bit older piece of software, but it runs on Windows PC. And it will help us determine a wow and flutter reference number for each one of the devices. Wow and flutter is a really good wow and flutter number for a tape recorder is about 0.1%, 0.1%. And that is almost not detectable by the human ear. But anything over 0.2% is detectable by the human ear. And that meaning detectable, like you can hear a little bit of waver in the pitch of sounds or tones, and you can tell that there's some wow and flutter that exists. And wow and flutter can be caused by a number of different things. For example, it can be caused by drive motors, worn out drive motor bushings or bearings. It can be caused by tape reels being out of round and rocking. It can be caused by the tape itself, which may be stretched or worn in some way. It can be caused by power variations on the device. And it can be caused by electronic irregularities that prevent the motor or the controls from operating consistently over a period of time. And so they introduce a waver or wow and flutter in the device. Drive belts, drive tires are also a very common failure point which produce and cause this waver or wow and flutter. So today, what I want to do is look at these tape recorders. We're going to create a test tape, a couple of test tapes for different speed machines. Some of my machines are running at 3 3/4 inch per second. Some of them are running at 1 7/8, and some of them are running at 7.5 inch per second. So I've got to create some reference tapes, reel-to-reel tapes, on a really good tape recorder, and you'll see that in a moment what we're going to use for that. And in fact, this tape recorder, I don't think I mentioned it in the recording where we create that test recording, but that test recording, that tape recorder was doing an average wow and flutter of 0.06. And remember I said that 0.1 is a great number. 0.2 is getting, well, you're starting to hear some wow and flutter. 0.1 is great. Well, this is 0.06, so it is greater than great, even though we're considering recording it and then playing it back. So the numbers that I'm going to show you later on a spreadsheet and a chart here indicate that our reference tape is really actually pretty good for a test of this sort, especially since we're working with these little vintage jobs like this little jewel. I call all my recorders jewels, but they are this little Continental, gorgeous little tape recorder. And I'm not sure this one will be in the test because it's not been repaired yet. But these little things create our playback, and they have all kinds of wow and flutter, and we're going to see how much they have. And so that's the purpose of this video today. I hope you watch all the way to the end, because at the end of the video, I'm going to give you the results of each tape recorder, and I'll show you the tape recorder and show you the results. And I think what I'm going to do with this one, and I've got a couple more here that haven't been repaired, I'm going to do a repair video, short repair video, but we'll just get it barely running. We'll call it a resurrection, just to get it running well enough to get it to play, and we'll run a test on the wow and flutter, and then I will address all of the electronic, mechanical, rubber tires, belts, issues and oiling and greasing everything to try to get an improvement on the wow and flutter for a couple of these, just to see that process, how that process goes. Okay, so let's jump right into the software that we're going to be using for the wow and flutter test, and we'll get our test tape made. I'm using a program that I downloaded. Let's see if I can find the information for you here. Alex Freed produced this a number of years ago, and it's very simple, but it really does what we need it to do. And so we'll start with a tone coming out of the frequency generator here, the Gwinstech frequency generator, and as you can see, I've got it set for around 3,000 hertz. We'll adjust that in a moment, and it's coming in and playing into a speaker, so a little speaker here, and we'll just use the microphone that we've got here, the old 1930s, 1940s Webster Chicago microphone. Doesn't have to be anything fancy, and it's plugged into the computer here, and it will monitor the frequency, and it will match this frequency here, as you can see, with the frequency from the generator. And then it'll listen, and we'll see a variation of the tone, either higher or lower, faster or slower, a deviation listed here. And then it'll give us a peak deviation on this gauge, and we'll set it to a specific range. We'll do all of that. And then the summary information is right here. It does a 10-second evaluation and gives us a root mean square, and then a quasi-peak reference in percentages. So let's get started with the reference tape reference machine. Now we're starting with the Nagra DJ, and I haven't done a full video on the Nagra, but just for reference sake here, Nagra is a studio quality, super high-end tape recorder. These can be found on the internet. Nagra is still a business that works out of Switzerland, and these are basically produced one at a time. They are incredibly high precision. So what I'm going to do this morning, because I don't have a test tape pre-made from the factory, what I'm going to do is I'm going to set the tone here for 3,000 hertz or thereabouts. It needs to be pretty close to 3,000 hertz. And then we'll record on the Nagra using the smaller tapes, and then we'll play it back into the program running over here on the PC. and we'll see how precise the Nagra is doing. Now keep in mind that the tape recording includes any imperfections and inconsistencies and any wow and flutter in this device. This is an older device. It's a 1980s device, so it's not perfect, but it has very high precision tape speed control, and so that's why we're going to use this. This is the closest thing I have to a lab reference. So we're going to record a tape, and that introduces wow and flutter into the tape because of the mechanics of the system, and then we're going to play it back, so that doubles the wow and flutter, if there is any, on this recorder and player. So that's the best reference point I have at this point in the study. So I hope that's clear. So we're going to record a couple minutes or so of a 3,000 hertz tone on this recorder, and then we're going to rewind the tape and we're going to play it back, and we're going to listen to it on the PC, and we're going to watch the performance of the wow and flutter and get a baseline for wow and flutter. All right, we've got the generator set on, let me turn this down. We've got the generator set on 3 kilohertz, or very close to 3 kilohertz. I can just barely bump it there. Okay, that's pretty good. 3 kilohertz, and it's playing on this little speaker, and then the microphone here is listening on our application. So let me turn the gain back up on the frequency generator, and this unit will start to hear it. All right, I'm going to turn it down. Now what we're seeing is the flatter this line is, the less amount of deviation there is in the frequency. So a perfectly straight line would be an absolutely perfect 3,000 kilohertz or 3 kilohertz signal with no deviation whatsoever, and then there wouldn't be any peaks of deviation listed, so the meter should read perfectly 0 and a 0 peak here. I'm at the lowest or the highest sensitivity range. The highest sensitivity range is 0.1%, and it will go all the way up to 4%. So the higher the number, the more distortion, the more deviation. The lower the number, the more pure and stable the signal is. So it's searching for a signal right now. That's why it's changing. So I'm going to turn the audio back on. Got a green light here, tells me I've got a good signal. My volume level is okay. Set on the lowest value. You can see there's very little deviation. And my peak is very low, almost negligible. And if we look closely at this reading, a 10-second reference, 0.0036 root mean square deviation with a 0.0074 peak. And that's probably because my voice is interfering with the signal as well. Now, just to give you an illustration of how wow and flutter affects the signal, I'm going to come over here and I'm going to wave my hand. I don't know if you can hear that on the tape, but I'm just going to wave my hand gently over the speaker, and it's going to cause the pitch to change. It's a Doppler issue, I think, and it's going to change that, and we're going to see it reflected on the meter. Ready? Okay, so you see the deviation occur when I interfere with the signal. All right, I'm going to turn the signal back off because my ears are about to explode from that pitch. So we're going to now, that's our reference point. And now what I'm going to do is I'm going to hook up the tone generator directly into the line input on the Nagra. And we're going to record a couple minutes of that pitch, just that pitch. Since we know it's almost perfect in terms of no wow or flutter. And then we'll see how the recording and then the compounded deviation on playback will show up on the Nagra over here on the PC. So I'm going to go ahead and record so you don't have to listen to that. And then I'll come back and we'll do a playback into the... Okay, I completed a recording and I've rewound the tape. A couple of minutes of the 3000 Hertz tone. And we'll see how it plays back on the PC. So let's start the playback. And let's go look at the laptop. All right, I'm on the highest sensitivity range right here. Okay, I'm going to rewind it. I'm on the highest sensitivity range, and you could see that I was peaking at 0.1 on the playback. So the deviation, you could see the deviation in the pitch of the signal. And let's look here at the frequency when I rewind it. Okay, so let's drop the sensitivity to get the meter down in range. Notice the deviation is much less, but we're not as sensitive. And now our peak, 10-second reading. Still 0.0621 RMS and 0.13. So it's just a little over 0.1 peak. So a perfect tape recorder with a perfect test tape would have a flat line here and zero wow and flutter. Of course, we're not talking about perfection here. We're talking about a recorded test tape and then playing the recorded test tape back. So we've got double wow and flutter deviation built into our test. But at least we have a reference point as to what to expect with these other tape recorders. So what I'm going to do is we're going to factor this air into the other tape recorders because we're going to use the Nagra to record test tapes that will fall into the range of 3000 Hertz or 3150, and that will be our test tape producer, and then we'll play it back on these other tape recorders, and we'll factor in this air into those to make it a fair test. I'm going to run a test on each one of these reel-to-reel tape recorders and get a feel for the quality of their recording and playback capability. These are represent a wide range of reel-to-reel tape recording technology in the 60s, early to mid 60s. So, and I have done videos on demoing most of these tape players, so you'll be familiar with some of those if you've watched that series. So let's go ahead and we'll go through. I won't video record all of the tests that I've done on all of these, but I'm going to go ahead and create a test tape for the different speeds that these different recorders run and record and playback. Some of them are recording in 3 3/4, some are recording in 1 7/8, some are recording in 7.5 inch per second. So I've got to create test tapes that will play back at around 3000 hertz, as we've just discussed. And then I'll display the results of all of these tests at the end of this video. Okay, I've reduced the volume of the tone just so I can talk over it. You can see that we've got the range set here, the different range settings, and it's exceeding the range settings, and now the frequency is above the evaluation frequency, so we're going to have to rewind the tape and try again. Now remember, one of the challenges we have with these tape recorders are that the rim drive, this playback speed increases as the tape builds up on the reel, so it's pulling more tape through per second than it originally is at the very beginning of the tape. So when I record tape on the Nagra, it's using a pinch roller, which provides constant tape speed no matter how far you are into the reel on either side. This produces constant tape speed from the beginning to the end of the reel, whereas a non-capstan roller, capstan tape recorder, rim drive, the tape starts slowly because it's pulling. This is pulling the tape through. It's not being pushed through with a capstan, and it's the diameter here is smaller, so it's pulling less tape through, and then as the tape gets larger and larger and larger on the spool, it's pulling more and more tape through quickly, so the pitch changes faster and goes faster and faster and faster. So to use this evaluation tool, it needs a stable frequency within a specific range, roughly 3000 hertz or 3150, and it will evaluate a 10-second segment of those tests. So what started out, we were in range around 3000 hertz. Now you can see we're at 3400 hertz because the tape speed is increasing. So I'm going to rewind the tape and reduce the size of this spool, and then we'll start the test over again just to make sure we have a good reading on the Brownie high fidelity model. What is that? 402, model 402. Alright, so we've rewound, we've reduced the size of the tape just slightly. Let's go for a few more seconds here. And you see my microphone here that's listening. The Wow and Flutter software is listening with this microphone. Alright, now let's try it. Right here, the pitch difference. We were at 34, now we're at 29. Alright, so let's switch over here to 3000 hertz. Wow, look at the Wow and Flutter on the 1% scale. Now let me quickly move to the 4% scale so we can get it in range. Alright, out of range. Just going out of range. So let me stop the tape. And notice our 10-second reading. We're at 1.1% RMS, and we had a peak of almost 2%. So the Wow and Flutter on this little tape recorder is pretty bad. Now there are a couple of things happening that I wanted to point out. If this, because it's a rim drive, If the tape is bumping on this reel anywhere, then it's going to increase and decrease the speed. And I think that's some of what we're hearing, that. So let me play it. See, it's pretty stable right there. And you can actually see the up and down of the reel moving. It's running a little better right there. But our software doesn't evaluate frequencies of 3400 and on up. It'll only evaluate a test tape of 3000 hertz or 3150. So that's the dilemma we have with these tests. Let's go on to the next recorder. All right, this is my favorite tape recorder of all of them. This is a Jewel. It's the Mayfair 200. So I'm going to set the tape microphone here. We're going to leave the software in the same 4% mode so that you have an immediate reference point from the Brownie. Okay, let's see where we're at here. Start the test. Notice the difference, much more stable. Now we're still at the 4% mark. Let's increase the sensitivity to 1%. We got a few spikes. Okay, we're going to stop it there, and let's look at the numbers here. 0.3, 0.4% RMS and 0.7% peak. Significantly better than the Brownie. The Mayfair is doing a pretty good job. I believe that one of these recorders, and I can't remember which one it is right off the top of my head, advertised less than 2%. So in this case, they would have beat that. This is probably more like less than 1%. So we're in pretty good shape. Still, you can still hear the tone on the recording, and this video recording, and you can see the deviation on the screen here. Remember that zero deviation means that there's no wow or flutter. And in this case, we know there is some wow and flutter. And keep in mind, this is a recording of an imperfect tape recorder to start with. So we've introduced some wow and flutter into the test, and we would need to factor that in. And now, just to illustrate why wow and flutter is an important number on the specifications of a tape recorder. This is the Aileron. This was the one that recorded and played back the worst wow and flutter numbers. I want you to listen to an actual recording. Okay, that's the recording on the Aileron, and we're recording off the AM radio again to do an A-B comparison. All right, that's the Aileron. So let's switch over here to the Mayfair, which did much better, did probably the best, one of the best recordings, best being a relative term. transistor tape recorder of the 1960s. So there you have a comparison. The high wow and flutter and lower wow and flutter. You could still hear the pitch rising up and down in the music in particular. And that's the nature of imperfect reels, old tape medium, and rubber tires, and all of those variables play into the quality of these older 1960s tape recorders. Here are the numbers of the readings from the software, from best to worst. Notice the Nagra and the numbers there compared to the Aileron, which is the one we just did a test for. Here's the graph representation. So you can see the Aileron right there at the very end, right here. The higher bar means more wow and flutter, which means poor quality audio. So this is the Aileron, and the RMS value is right at 1.5%, and the peak wow and flutter readings were in excess of 3%. Then we go all the way down to the Mayfair, which we just also tested. And the Mayfair, you see the numbers are significantly lower. And they're still higher than of course, the original test of the Nagra. So let's just take a quick look at a couple of the other tape recorders so that you have a reference on which one is which. The Craig 212, which is a capstan drive, fared pretty well. It did. It was neck and neck with the Mayfair. Actually, the Craig peak number, as you can see, was better than the Mayfair. So the Craig was a little better than the Mayfair. And then surprisingly, the Book Quarter, which is this little jewel here. Remember the hidden tape recorder in a book form? Surprisingly, that did very well, comparatively speaking, with a 0.5% RMS, but pretty high, 1.2% peak to peak. Then we went to the Lloyd's, which is over here. The little Lloyd's, what I call the Mission Impossible tape deck. I don't think this was in the Mission Impossible, but it's very similar to one that was in, and it came in right here. And then there's the Brownie, which we just saw, the Brownie. And Brownie did okay. It's just barely under 2% wow and flutter. Then the Valiant, which is probably the oldest of all of these. The Valiant jumps right in here. Then there is the Ross, which is this tape deck right here. You remember? And then the GE, which this really surprised me. The GE, I figured since it was a capstan drive, would have come in much better, but it is second to worst with the Aileron. So there you go. There are the numbers. Thanks for taking the time to look over all this. I really would be interested in your comments. If you have any opinions about the tests, I realize the test is not, a superior scientific test. There are a lot of different ways that I would do this if I were a more laboratory environment. But I just wanted to kind of do a course evaluation of all of the tape recorders, and we'll see how they stack up with some of the others that I haven't yet repaired. Well, I hope you enjoyed this series of tape recorder wow and flutter tests. I've got a couple of more tape recorders that I will feature in upcoming videos. And I may do a WoW and Flutter test before and after, just to give you an illustration of doing a before repair and then an after repair to see if we can improve the overall recording quality and in WoW and Flutter. So again, thank you for watching, and give me a thumbs up.